Everyone, welcome to Curiosity. Let's solve question 185, Department Top 3 Salaries. The question says, a company's executives are interested in seeing who earns the most money in each of the company's departments. A high earner in a department is an employee who has a salary in the top 3 unique salaries for that department. We need to write a SQL query to find the employees who are high earners in each of the departments. We are free to return the result table in any order. So this question is very similar to LeetCode question 184, where we were asked to find the highest earners in each of the department. So I'm going to link that video and I highly encourage you to have a look at that video as well. So with this question, we are asked to create groups for each department, and within each of the departments, we are asked to find those employees who have salaries in the top 3 unique salaries for that department. So to achieve this, we would have to use one of the window functions like rank or dense rank. And what I'm going to do now is show you an example and try to explain why we would prefer using one type of window function over another. So let's jump into the example. So consider we have the input table employees. So consider this is our input table where we have 5 employee records. And what we're going to do is we are going to construct 2 additional columns called rank and dense rank. And I'm going to try and compare which would be the better window function to use. So as you can observe, I've created 2 columns, rank and dense rank. The rank column is constructed using the rank window function. The dense rank column is constructed using the dense rank window function. So first, let's look at how the rank function is computed and the different ranks. So we see that there are 2 employees, Joe and Max, who have the salary of 90,000, and this 90,000 is the highest salary. That's the reason why both of these employees are given a rank 1. We can observe that the next highest salary is the salary 85,000 corresponding to the employee Randy. And we can observe that the rank given to this employee is 3. So one thing to notice here is that there is a hole or there's a gap between rank 1 and rank 3. And the reason for this is because how the rank function works. Since there are 2 employees with the same salary of 90,000, the next rank that is going to be assigned, which is assigned to Randy, is going to skip one number because we have 2 employees with the same rank. It's going to skip one number and the next rank is going to be 3. And this is something that we don't want to solve this particular question. What we want is to find the top 3 unique salaries for within each department. And to do that, we can use something called a dense rank. So with dense rank, you can notice that again we have rank of 1 given to Joe and Max because they have the highest salary in the department. But the next rank for Randy is 2. And this is where dense rank differs from rank, is there is no hole or there is no gap between rank 1 and the next rank. So this is the key difference to understand. And if we can construct an intermediate table like this with the dense rank column, what we can then do is we can simply filter all the records for each department where the dense rank or the rank is basically less than 3. So we would filter this record. So we would basically filter these 2 records. We would also filter these 2 records. So, and that is what is expected from our in our desired output. So let's go ahead and start writing the SQL query. I'm going to start off with saying select star, using star as our placeholder, from the employee table. And since we need to, since we have 2 different employee tables, we need the name of the department. I'm going to do a left join on the department, alias it as D. Let me just correct these mistakes. So left join on department D, and I'm going to join it on the department ID column. So E dot department ID equals to d dot id. And what I'm going to do is I'm going to select the columns that we need in our output, the desired output. So first we need the name column. So I'm going to say e dot name as employee. We also need the department name. So I'm going to say d dot name as department. The employee name. So we have department here. So we have department, we have employee, and we need the salary. So I'm going to say salary e dot salary. And now to construct the dense rank column, I'm going to use the dense rank window function over partition by the department ID, since we want to create groups for each department, and order by salary in descending order, since the person with the employee with the highest salary should be given a rank 1. And I'm going to alias this as dense rank. So we have the intermediate table with us now, and I'm going to create a common table expression for this intermediate table that we have, so it will be easy for us to filter this table. So now that we have a common table expression, I'm going to select star from CTE and use a filter to find only the records where the dense rank is less than or equal to 3. And we need the columns department, employee, and salary. So basically we need all the columns except the dense rank column from our intermediate table. So let me go ahead and try running this query to see if we can get the expected output. Okay, we see there's an error here. Let's try and fix it. Okay, so the issue seems to be that this dense rank alias is not getting accepted for some reason. So let me just go ahead and say dense rank, and let's change this as well. And let's now try to run our SQL query. Okay, so the test case is passed. Let me go ahead and try submitting it. Okay, so our runtime is good and the solution is accepted. So thank you everyone.